Today we're going to have the lesson 16 homework solution, the solve systems of equations algebraically. The prerequisite is find the number of solution of a system. Remember that we start the homework by studying an example showing a system of linear equations with no solution. In this case is no solution. Then solve problems 1 through 6. So the example says graph the system of equations below to show that it has no solutions. And I have y equals 2x plus 4 and then y equals 2x minus 1. And the problem says the lines do not intersect, so there is no ordered pair that will satisfy both equations. The system of equations has no solution. We mentioned in class that we have 3 kinds of solutions: no solution, one solution, infinitely many solutions. In this case, the example is no solution. Why? As you can see, we have 2 parallel lines. Parallel lines, they never intersect each other. So you're not going to have the ordered pair x comma y that satisfies these 2 equations. And as you can see, you have the space between the 2 lines. How do you graph them? Okay, or what are the characteristics? That's the most important. The slope are the same. The slopes are the same, and the y-intercepts are different. See, the y-intercepts are different, and the slopes are the same. Now, how do you graph it? For example, equation number 1, you go to plus 4 in y, that's your y-intercept, plus 4, and then you go 2 units up, you count 1, 2, and then 1 to the right. And then you, with a ruler, you just draw the line. See, well, that's the first line. And then you take the second equation, y equals 2x minus 1. So you go to -1, then you go 2 units up because the slopes are the same. The slopes are the same. 1, 2, and then to the right 1. And then you draw the line, and you have the equation number 2. Parallel lines, no solution. Problem number 1. Now we're going to solve problem number 1. In this case, what I have, what type of lines are shown in the graph of the system of equations in the example? In this case, okay, parallel lines. So I'm going to write here parallel lines. Okay, problem number 2. The graph at the right shows the system of equations y equals x minus 3, y equals -3x plus 1. What is the solution? That's the first question. What is the solution? Number 2, explain how you can verify that if it's a solution to both equations. So in this case, look where the graph intersect at this point. And then you reflect through the x and y axis. Remember, this is x, this is y, and what I want is x comma y, the point x comma y. So you just go over here, and in x is 1, and in y is -2. So the solution is 1 comma -2. So in this case, 1 comma -2. There is a second part to this problem. It says explain how you can verify that this is a solution to both system of equations. And in this case, my solution is going to be, I can make the substitution. Okay, I can substitute 1 and -2 into both equations. To see if the results are true statements. Okay, and I'm going to do it. So in this case, you have y equals x minus 3. I'm going to type it here, y equals x minus 3. And then I'm going to make the substitution. I know that x is 1 and y is -2. So I'm going to have y is -2 equals question mark, as we do in class. And then we have x is 1 minus 3. Okay, this means then I have -2 is equals to 1 minus 3 is equals to 2. And that one is a true statement. Okay, that one is a true statement. So it satisfies the first equation. We need to prove the second equation. The second equation is y equals negative 3x plus 1. That's the second equation. So this one, I have negative 2 equal question mark, and then I have negative 3 times 1 minus 3. And what that means, therefore, I have negative 2 equals question mark, because I see that there is one operation, negative 3 times 1 is negative 3 minus 3. Okay. In this case, what we're going to have, this is 1, plus 1, plus 1, so this is plus 1. So I have wrong, plus 1, negative 3, plus 1, and negative 3 plus 1 is negative 2. So this one means negative 2 is equals to negative 2. So this one is correct. This is another true statement. Okay. So in this case, the solution to the system of equations is correct. Remember, system of linear equations is a set of two or more related linear equations that share the same variables. Y equals 3x minus 2, y equals x plus 1. That's page 177. Let's move to page 178. Remember, we have some homework on this one. Number 3, I have the graph at the right shows this system of equations. Explain what the graph tells you about the two equations that form the systems and about the number of solutions the system has. So I have y equals 2x minus 3. The second equation, I'm going to apply the distributive property, like 1/2 times 4 and 1/2 times negative 6. So what I'm going to get, therefore, I have y equals 1/2 times 4. I'm going to do it here. 1/2 times 4. I'm going to write a denominator 1. 1 times 4 is 4. 2 times 1 is 2. And 4 divided by 2 is 2. So I have 1/2 times 4 is equals to 2x minus. So minus. And then you have 1/2 times 6. Same situation. Denominator 1. 1 times 6 is 6. 2 times 1 is 2. 6 divided by 2 is 3. So minus 3. As you can see, the two linear equations are the same. So it's the same linear equation. Now it's written in different form. So I have the same slope and the same y-intercept. So you have the same line. You don't have to write two lines because it's the same line. So it's only one. So explain what the graph tells you about the two equations that form the system and about the number of solutions the system has. So in this case, I'm going to have, because there is only one line, there is only one line, okay? Because there is only one line in the graph, I know that the equations are, the same. And there are infinitely many solutions. There are infinitely many solutions. Okay, infinitely many solutions. Now let's go to number 4. This is a basic problem. I have described two ways in which you can determine how many solutions a system of equation has. So in this case, we're going to have, I can graph, number 1, I can graph the equations or I can compare the slopes I can compare the slopes in this case and the y-intercepts of the equations. Okay. Remember that we mentioned in class that if you have the same slopes and different y-intercepts, those are parallel lines, so there is no solution. And if you have the same slope and the same y-intercepts, then you have infinitely many solutions because it's exactly the same line. Let's go to problem number 5. We still got problem number 5. How many solutions does this system of equations have? Explain how you know. Again, now remember that we need all those equations in a slope-intercept form. And when I mention a slope-intercept form is y equals mx plus b. Y needs to be alone. In this case, the second equation is alone, but in this one is not. I have y plus 2x equals to 5. So I need to get rid of this 2x. You have covered the variable. You have plus 2x, so we're going to use minus 2x minus 2x, both sides of the equation. So therefore, this is y equals negative 2x, and I'm going to put this x in front, okay, because it's mx. So minus 2x plus 5. Plus 5 because 5 is positive. So I have y equals 2x plus 5. Let's compare the slopes, negative 2 and 3. The slopes are different. The y-intercepts are the same. That means you're going to have only one solution. Now let's answer the question. In this case, I'm going to say, how many solutions does this system of equations have? One solution. Explain how you know. And I just mentioned it. Now we need to write it in that piece of paper. So in this case, I'm going to say I wrote y plus 2x equals to 5 in slope intercept form. Okay, and compare the slopes and y-intercepts. The slopes are different and the y-intercepts are the same. Therefore, this means that there is one solution. This means there is one solution. Okay, done with problem number 5. Problem number 6, we have kind of application problem. Okay, so I have Jason and Sylvie work together to write a system of equations that has no solution. Jason wrote the equation y equals 4x plus 2. Sylvie wrote the second equation. We don't know, it's not there. Write a possible equation that Sylvie might have to written. Explain your reasoning. So in this case, for number 6, you should have equations that have a slope 4, the same slope, and different y-intercept. So in this case, for example, I'm going to say possible solution is y equals 4x minus 3. Okay, same slope form, different y-intercepts, so from plus 2 to negative 3. So in this case, I'm going to write here as an explanation because it says explain your reasoning. The equations in a system that does not have a solution have the same slope and different y-intercept. Okay, that's page 178. We're going to continue at page 179. So we have use substitution. That's what we did the second part of the class. Okay, the first page is just a review of the lecture, still part of the homework. Then I have use substitution to solve the system of equations. You study the examples showing how to use substitution to solve a system of equations, then solve problems 1 through 6. So it says solve the system of equations, and you have two equations, y equals x minus 3 and y plus 2x equals 3. Then you follow the pattern of the example. So we have noticed that the first equation tells you that y equals x minus 3. This equation is already solved, as I mentioned. Y is alone. Okay, y is alone. So substitute x minus 3 for the y second equation and solve for x. So what I did, you have the second equation, right? Y plus 2x equals 3. Y plus 2x equals 3. What I do here is telling me that y is equals to x minus 3, and that's the substitution. X minus 3 plus 2x equals 3. Simplify. So x plus 2x equals 3x, minus 3 equals to 3. Plus 3 equals 3x equals 6. And then divide by 3 both sides. 6 divided by 3 is 2. X equals 2. Remember that we need to find the value of y. Now you know that the value of x, you can find the value of y. So you have y equals x minus 3. I know that x is 2. So 2 minus 3 is equals to negative 1. So the solution is the order pair 2 comma negative 1. Problem number 1. Substitute the value of x in the example into the second equation, y plus 2x equals 3. What value do you get for y? Is it the same solution as in the example? Problem. So in this case, what do I get? Remember, substitute the value of x into the equation, y plus 2x. I'm going to write it here. Y plus 2x equals 3. And what they're asking me is to do y plus 2 times 2, because that's the value of x, okay, equals 3. 2 times 2 is 4, so y plus 4 equals 3. How do I solve for y? Cover y, use the opposite number of positive 4. Minus 4 minus 4, so y is equals to 3 minus 4, negative 1. So you get the same. So in this case, y equals negative 1, because it says, what value do you get for y? Y equals negative 1. And then explain, is it the same solution as in the example problem? I'm going to say in this case, yes. Okay, done, problem number 1. That was a basic problem. Then we have problem number 2. It's also a basic problem. The solution in the example is 2 and negative 1. Explain what the graph of the system of equations looks like. So in this case, you're going to say that it means, in this case, it means that the system of equations has one solution. And that a graph of the system will be two lines that intercept at the point 2 comma negative 1. This is negative 1. Okay, 2 comma negative 1. Number 3, look at the system of equations below. Describe how you can use substitution to find the solution, then find the solution. So you have this one. Which equation? That's my first question always. Which equation is already solved? Is the one that y is alone. Y equals x minus 4. So I'm explaining that solution. X minus 4 can go into y here. So you are going to have x minus 4 minus 3x equals to 4. Okay. So in this case, I'm going to say I can substitute x minus 4 into y in y minus 3x equals to 4 and solve in this case to find the value of x. Okay, period. Okay, then I can make the substitution back to find the value of y. So for example, I'm going to write it here. I'm going to have, this is y minus 3x. I'm going to write here, y minus 3x equals to 4. So what I'm going to do is x minus 4. See, I'm doing the substitution already. Minus 3 equals to 4. Okay? Minus 3x. This is minus 3x equals to 4. Then what is x minus 3? Is negative 2x minus 4 equals to 4. Cover your variable. Plus 4 plus 4. Okay? Crossed out. Minus 2x is equals to 8. And then we divide by negative 2. And we're going to have, I'm going to do here, x is equals to 8 divided by negative 2 is equals to negative 4. That's the first equation. That's the first solution. X equals negative 4. Now I need to find the value of y. That's x. So I know the equation y equals x minus 4. So y is equals, what is the value of x? Negative 4 minus 4 minus 4. So y is equals negative 8. That's the second one. So my solution is negative 4 in x, negative 8 in y. See? 179, that's page 179. We end up with a substitution problem. Let's turn the page around. We have more problems. Use substitution to solve the system of equations. Y plus x equals to 3 and y equals 1.5x plus 1. Show your work. Now we're going to show you work. So in this case, see, this one is already solved. So what I'm going to do is plug in this equation into this y. So let me do it here. So I have 1.5x plus 1 plus x is equals to 3. See, I just did 1.5x plus 1 plus x equals to 3. Let's simplify because 1.5x and x are like terms. So in this case, we're going to have, as you can see, 1.5 plus 1 is 2.5. So I have 2.5x plus 1 equals to 3. Okay, then cover your variable. Minus 1 minus 1 minus 1 minus 1 crossed out. So I have 2.5x equals to 2. And then what are we going to do? We're going to simplify. 2.5 is multiplying. We're going to divide 2.5 divided by 2.5. So we get 2.5 divides, and I have 2 divided by 2.5 equals to 0.8. So x is equals 0.8. I have the value of x. Now to find y, I go to y equals to 1.5 x plus 1 and plug in equals to 1.5 times 0.8 plus 1. So y is equals to 1.2 plus 1 and y is equals to 2.2. So my solution here is 0.8 comma 2.2. That's using substitution in problem number 4. That's a medium problem. Then we have problem number 5. It's another medium problem. So we have here the system of equations at the right shows x by itself on the left side of one of the equations. Solve the system by substituting x instead of y. So in this case, x is already solved. X is already solved. So x is equals to negative y minus 2. We're going to use exactly the same. It's the same steps. So I'm going to use the second equation here. So I have 0.5 x, but x is equals to negative y minus 2. Negative y minus 2, close parenthesis, plus y equals to 1. Then we multiply. 0.5 times negative 1 is negative 0.5y. Then 0.5 times negative 2 is equals to negative 1 plus y equals to 1. And then you do y plus negative 0.5y, or negative 0.5y plus y is equals to 0.5 in this case. Okay, we're going to have 0.5 y, and then you have minus 1 equals to 1. Then cover your variable, plus 1 plus 1. So we're going to have this cancels out, 0.5 y equals to 2. So what we're going to have, that we divide 0.5 and y is equals to 4. That's the solution for y. Now we need to find x. So here is x. So x is equals to negative y minus 2. Y is 4. So x is equals to negative 4 minus 2. So x is equals to negative 6. So my solution here, my solution is negative 6, comma 4. Okay, that's the equation to the system of equations. Let's go do number 6. This is more complex problem. As a complex, it says Fina, I think it says Fina wants to use substitution to solve the system of equations at the right. Explain what she needs to do first before using the substitution, then solve the system of equations. So I have 2x minus y equals to 3. Then I have negative 1.5x plus 3y equals to 18. So in this case, I'm going to say it, right? I'm going to say, Fina, I'm reading it in Spanish because I don't know how to say it in English. Fina needs to write one of the equations so that it has one of the variables by itself or alone, as I mentioned, in one side, on one side. Okay, then the easiest change comes to this equation. So I'm going to do it here. So you have negative y. So I'm going to solve for y. Okay, so cover your variable. You have 2x. So we're going to use minus 2x. So minus 2x minus 2x. So you have negative y is equals to 3 minus 2x. Then you have that negative 1. So that negative 1 you get rid by multiply by negative 1, both sides. Negative 1. So you have negative and negative is positive y equals to negative 1 times 3 is negative 3. Negative 1 times negative 2 is positive 2x. So this equation is y equals to 2x minus 3. So that's solving it in a slope-intercept form. So in this case, what we do, make the substitution to 1.5x, negative 1.5x, and then we find the solution of that system of equations. I'm going to use this piece of paper, separate piece of paper. I'm going to use minus 1.5x plus 3y equals to negative 18 because I don't have a space in that. And then I have that y is equals to 2x minus 3. I know y. So I'm going to have minus 1.5x plus 3 y, but y is 2x minus 3 equals to negative 18. Then we apply the distributive property. So negative 1.5x plus 6x minus 9 equals to negative 18. 6 minus 1.5, in this case, is equals to 4.5x. Okay, then we do plus 9, so this is equals to negative 9. Okay, and then we divide 4.5, divide by 4.5, divide by 4.5. So 9 or negative 9 divided by 4.5, and this one is 2. So x is equals to negative 2. That's the first value, okay? Negative 2. Now this one, I'm going to plug it in this equation. So y is equals to 2 times negative 2 plus 3 or minus 3. So y is equals to negative 4 minus 3. So y is equals to negative 7. So what is the order pair? It will be negative 2 in x, negative 7 in y. And that's the solution of the system of equation. I'm going to write it here. So the solution is negative 2, comma, negative 7. Okay, that's the solution for the system of equation by substitution. This is your homework, and remember, connect to Zoom. And if you have any questions, you can let me know. I will be glad to answer back. Okay, it can be in the comments or it can be in Google Classroom. And I hope you have a wonderful night.